Okay, so we're now going to calculate the index of diversity. So as we said in the previous video, we're looking at these fungi. So you've got a number of fungi over here. You've got community A, which has got lots of yellow fungi, one orange, one brown, one purple. And then you've got community B, which has got equal numbers of all of the different fungi. So we're going to calculate the index of diversity for each community. And then using that number, we'll be able to say which one has got the highest index of diversity. Remember, index of diversity takes into account two things. It takes into account species richness, which is how many different species there are. So for each one, there's 4 different species, but it also takes into account the abundance of each species. So it takes into account how many of each individual there is in a particular species. So we're going to use this equation over here. And so let's see how we actually use it. So let's look at community number 1. That's number A, sorry. Let's look at community A. So community A has got the 4 species here. They are yellow, orange, brown, and purple. So we're just going to count up how many different, how many of each species there are. So let's look at the yellow in community A. And if we count all of these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, count them all up, you will find that there are 17 of them. So there's 17 yellows in community A. You can see that there's 1 orange, there's 1 brown, and there is 1 purple. Okay, so in total, if I add all of those up, I have got 20 different specimens. Okay, so in total, it's a total number of all species, and that is n. So n is equal to 20. If we do the same thing for B now, so if we count up how many there are of the yellow species, of the orange species, of the brown and the purple. So we look in community B, we can see that we've got 1, 2, 3, 4, 5 yellow, 1, 2, 3, 4, 5 orange, 5 brown and 5 purple. So we do the same over here. There's 5 of those, 5 yellows, 5 orange, 5 brown, 5 purple. And if we add all of these up, we have got n again is equal to 20. So in both cases, we've got 20 in total. Okay, so 20 of all the species, right? Now we're going to look at how to calculate the denominator of this. So this n minus 1. So we're going to be summing together all of these n minus 1. So how do we work this out? So n is the number of each individual species. So in community A, there are 17 yellow mushrooms. So that is small n. Okay, so this is small n over here. So I should have been a bit more clear about that. So this is small n. Okay, so we want to work out n minus 1, n bracket n minus 1. Okay, so we will, for the yellow one, it will be 17 bracket 17 minus 1. Oops, that didn't work out very well. I can't see my minus sign, sorry. Minus 1. Okay, for this one here, you've got 1 bracket 1 minus 1. For the brown one, 1 bracket 1 minus 1. So 1 is the n, bracket n, 1 minus 1, and it's the same for here. Okay, so if we do these sums, we end up with 17 multiplied by 17 minus 1. So that's 17 going to be multiplied by 16. So 17 multiplied by 16 is 272. Okay, This calculation is 1 multiplied by 1 minus 1. 1 multiplied by 0. So 1 multiplied by 0 is 0, because anything multiplied by 0 is 0, 0, 0. Okay, so this here is also n minus 1. Okay, that's just showing you how to do it. This is the number. So to get the sum of those, we add all of these together. So 272 plus 0 plus 0 is 0. Well, that's equal to 272. Okay, all right. So now let's put these numbers into this equation. So the equation is D is equal to big N minus 1 over sum of small n minus 1. Okay, so our big N is 20 because there are 20 in total, 20 mushrooms in total, multiplied by big N, 20 minus 1, all over, well, we've worked this out. That's what this was, sum of. So we've summed together all the n minus 1s. So we've added all those together and they're 272. So that's 272. So that is equal to 20 multiplied by 20 minus 1 is 19, divided by 272, and that is equal to 380 divided by 272, which is equal to 1.4. Okay, so community A has got a diversity index of 1.4. All right, so now let's look at community B. So for community B, we've counted up that we've got 5 yellow, 5 orange, 5 brown, 5 purple, and we'll do the same thing. So we'll say for each one of them, 5 bracket 5 minus 1, and this one as well, 5 bracket 5 minus 1, 5, 5 minus 1, 5, 5 minus 1. Well, hopefully you can see here, 5 multiplied by 5 minus 1 is equal to 5 multiplied by 4, which is equal to 20, and they are all the same, so these are all 20. So here we're working out our n minus 1. Okay, so there's our n minus 1. You've got 20 plus 20 plus 20 plus 20, summing all of the small n minus 1s together, and you end up with 80. Okay, so let's do the same thing. Let's work out the index of diversity for community B now. So we're going to use the same equation. So using that same equation, we have got, again, big N is equal to 20 because we have 20 different species, so 20 in total, and so it's 20 multiplied by 20 minus 1 divided by the sum of n minus 1. Well, we've done that. Here's the sum of n minus 1, so that's divided by 80 in this case. So we're going to end up with, again, 380, because we worked it out over here, divided by 80, and we end up with a number of 4.75. Okay, so we've got two numbers, 1.40 and 4.75. The higher the index of diversity, the higher the number, then the higher the species diversity in that particular community. So we can say that community B has got a higher index of diversity than community A. Now in this particular example, you just need to look at it and you can see that. You can see that there is good species evenness here. So there's equal numbers of each type of species. Whereas in this one over here, you've got dominance of one particular species. So you have much less diversity here. So by looking at these pictures, obviously we could tell that, but these numbers confirm it. And normally when you'd be studying a community, it wouldn't be this blunt or obvious. Things wouldn't jump out at you this clearly. You really have to look around in a community to try to find things, to count them. And very often you're doing massive numbers. You're getting really, really big data sets. And so you'd feed your data into this equation. and it would generate some numbers, and then in comparing them, you'd be able to say which has got the highest index of diversity. You might, while you're learning about this topic, if you watch other videos, if you look at other textbooks, if you even look at other exam boards, you will see a different equation. There are other indices of diversity. Some of them are inverses of this, so literally upside down. Some of them use logarithms. So there are a lot of different ways of measuring it, but this is the AQA preferred method. So this would be the one that you'd be expected to use in an exam. Okay, so what I'd like you to do now is go through the worked example in the textbook, very similar to this. Make sure that you understand it using the worked example, and then there is a summary question that I'd like you to do on calculating this, and there is also one exam question in what I've given you today. Okay, so good luck with this. Hope it's helped, and I will stop recording now.